Fatma, where
Fatma,
were you?
where were
Oh my God.
you?
Okay, Fatma, where were you?
Accidentally.
Where
Sorry.
were you? Tell me this first.
Using the restrooms, I lost track of time. Apologize.
Okay, accepted then. Alright, so today we are going to start with temperature, and I hate this chapter. I tell you why in a bit. First of all, I will tell you what exactly temperature means. So there are two definitions. Both of the definitions are viable and you can write them. The first one is it is the average kinetic energy of particles of a body. That's the first definition. The second definition, which I prefer, is that it is the degree of hotness or coldness of a body due to the root mean square speed of all particles of that substance. Because we have learned that kinetic energy, which was half m root mean squared, is equal to 3 by 2 kT, if you remember from the previous chapter. Alright, please write this down. Now, the next thing we should know is the triple point. And triple point basically is a unique temperature of a substance instead writing unique will add of a specific pressure as well. Unique temperature at a specific pressure where all the three states of matter coexist. Basically, this means that at this temperature, the solid, liquid, and gas can coexist. Okay. Now, I just want to tell you, this is just extra information. Whether you write it or not, it's alright. But for water, this temperature is 0.01 degrees Celsius and at a pressure of 0.161 kilopascals. This is just an extra information, because we generally like to compare everything with water for some reason, I don't know why. Now, so going to the next thing, and that is, yes.
So you said that all three states of matter coexist. So do they coexist as solid, liquid, or gas? Or like they all remain their own state of matter, but just like this there?
Yeah, that's correct. Because you see, have you ever been to north, like in the mountains?
No.
Okay. if you go to north
But it
next,
is
yeah,
icy.
yeah, it's of course icy, but you will also notice something. From the north, there are three things happening. So there's ice on the mountains. There's also rivers flowing from there, and from the top of the mountain, you will notice that there are clouds forming as well.
Yeah, right.
How is that even possible?
No,
Because
I never thought of that.
because the water is at triple point at some points. That's why. Is it clear?
Yes, sir.
Okay. Well, that's something cool, right? Next time when you go to north and you see this happening, you'll remember me then. Okay. Now, Kelvin scale. Kelvin scale is basically a thermodynamic scale. And you've been writing about it for some reason, and now you'll understand what exactly this means. Thermodynamic scale means that it is independent of any thermometric property. Okay, I'll tell you what thermometric properties mean. Just hold your horses, but we're going to write that it must pass through 2 points actually. One, absolute 0 kelvins. Okay. Number 2, triple point of water. Now, so if you like to, basically I'll tell you that later, but let's talk about thermometric properties. So I'm going to list them. The list of thermometric properties include pressure, length, volume, EMF, which is electromotive force, basically voltage in short, resistance, and light intensity. Okay. Now, what does these mean? So when you heat something, right? So its pressure increases. You know this. The material might change its length, or the volume changes, or the voltage changes in case of thermocouple, if you remember from O levels. Even the resistance changes, because probably, let me see, Nashmia late, very bad. And Suman, do you, okay, this would be sexist, but anybody plays video games?
Yes, sir.
Okay. When you're playing a video game, whether you're on PC or a console or mobile, do you feel that the device gets heated up, right?
Yes, sir.
This is because if the larger current passes, the resistance increases, and the temperature increases and stuff like this. So many things basically change temperature. The temperature changes because of this. Now, a kind of temperature that does not depend on this is basically called thermodynamic scale, which is kelvins, right? So that's what you need to remember. Now, there are a couple of thermometers that we need to learn. Why do we need to learn this? Because he's going to give you a situation, and then he's going to ask you which thermometer is best to use in this certain situation. So you guys need to learn the properties by heart for some reason, okay? Hate
Can you
CIs.
explain again what is thermometric scale? Yes, sir.
Basically, what I mean by this is that suppose, all right, you push something, right? You press a balloon. Would you increase the pressure inside?
Yes.
Now, the thing is that thermodynamic scale basically will not be affected by an external factor like increasing the pressure. Do you understand?
Yes.
Just like if you stretch something and the length increases, the thermodynamic scale will still be the same, irrespective of what the length would be. Do you understand? So let's suppose if I go and get two types of thermometer. I say, okay, I'm gonna get a 100 centimeter length thermometer and a 50 centimeter length thermometer. It might affect other things like the range of the thermometer, maybe the sensitivity and stuff, but the thermodynamic scale is not affected by it. It will still give you the same temperature if it increases or decreases. Do you understand what I'm saying?
Yeah, so this happens only in Kelvin scale.
Yes.
That's what they're right.
Exactly, because other scales basically are dependent on thermodynamic scales, and they function differently depending on the type of thermometer there is. Okay. Now, so it is possible for two different thermometers to give you a different reading of Celsius, maybe, but the thermodynamic scale has nothing to do with it. That's the point, right? So thermodynamic scale will always give you the same temperature whatsoever. Okay. Now, the first kind of thermometer is the liquid in glass, and this is the most common, like the commonly used thermometer in laboratories and in our clinics, but we are only talking about laboratory here. So the range is minus 10 degrees Celsius to 110 degrees Celsius, because we need to cover boiling point and the melting point of water. It has low sensitivity. I will also define what is sensitivity and responsiveness. So this has low responsiveness, and then it is easy to carry because it is very small and light, and it has low accuracy. Also, it is linear. Okay. Linear means that it changes its temperature equal to equal length every time for the same amount of temperature. Then we got thermocouple. Most of the questions will basically, if they ask you what is the best thermometer, you will always write thermocouple, because the range of thermocouple is minus 200 to 1750 degrees Celsius, which is a lot. It has quite the high sensitivity, and then
Does that cold even exist?
yes, why not?
Wow, I didn't know that.
Yeah, you don't want to melt metals.
Yeah, but like I like for some reason it didn't sink into my head that it would be that low.
Yeah, it is. It is that high and low as well. It is high accuracy. Most of the industrial use is from thermocouple. So it is linear high. Basically, you need to. It is easy to remember because you just need to appreciate this. Okay. So whatever you have learned, just write. It's very good in it. So platinum resistance. Platinum is a substance. It's a metal, right? And temperature can change its resistance. So the range of this is about minus 200 to 1000 degrees Celsius, because after that it melts itself, and it is high sensitivity. It's moderately responsive. It's easy to carry. It's very small actually. And then it has moderate accuracy, and it is non-linear, because in AS you might have learned this graph of current voltage like this, right? So it's basically temperature changes, doesn't stay